A canyon this deep does not forgive weak engineering. The route looks simple on paper, but impossible in terrain. Before construction began, engineers had to measure the mountain itself.
Confirmed.
The first machines did not build the bridge. They built access. Every beam, cage, and tool had to climb into the mountains.
Slow, watch the left side.
All right, lift it slow. Hold it right there. Watch the edge.
Survey points lock the future towers into the canyon landscape.
Reading confirmed. Okay, drive the stake there.
This temporary site became the launch point for the entire bridge.
Reading confirmed, securing the tripod now.
The foundation could only begin after the rock was proven strong.
That confirms the anomaly. It extends deeper than we thought.
Drilling rigs cut into the mountain to prepare the tower foundations. Excavators cleared the base pit, step by step, into solid rock. Dense reinforcement cages gave the foundation its hidden strength.
Consistent with the specs?
Formwork shaped the concrete mass that would carry the tower.
All right, hold it steady there.
Concrete was pumped into the base under strict control.
Here's in deep now. Move the boom slightly to the right.
Engineers checked elevation, alignment, and every critical tolerance.
Adjusting the tolerance levels now.
With the base complete, vertical tower construction could begin.
The far side. Looks consistent with the structural design.
But a suspension bridge also needs the mountain to hold its cables.
Bar cages before we start the next pour. Confirm the tensioning specs are met.
The anchorage pit was carved directly into the steep slope.
Hold it steady now. Lower it slow.
Steel anchor frames prepared the force path into the rock. Concrete locked the anchorage system into one massive block.
Moving the hose up.
Engineers inspected the anchorage before any cable could be loaded.
Confirmed within tolerance, copy that, over.
This block would resist the pull of the entire suspension system. Next, the towers had to rise above the canyon air.
And the load transfer down to the foundation needs to handle the stress.
Climbing formwork allowed the concrete tower to grow section by section.
Clear the area below.
Tower cranes lifted materials where trucks could never reach.
Secure the tag lines. Secured.
Every worker moved with harnesses, platforms, and strict safety lines.
Ready for the next pour.
Fresh concrete was poured high above the valley floor.
There. Vibrate that section.
Fog and wind turned height into a daily construction risk.
Rigging, Tower 1, confirmed secure. Proceed.
At the tower top, crews prepared the saddle zone.
Tension check complete, lowering 5 meters. Hold steady, we're almost aligned.
Two towers now faced each other across the empty canyon. The next challenge was creating a working path through open air.
Increasing tension now.
Engineers planned the temporary route before any catwalk existed.
Markers on the far tower.
We're showing 30 kilonewtons on the line.
A thin pilot line was pulled across the canyon first.
Clip your harness to the main line.
Sidelines, safety nets, and support ropes followed.
Watch the tension on that cable, pull it tight. All right, secure that mesh panel tight.
Short catwalk sections began to grow from the tower platforms.
Watch it, wind's picking up the fog.
Workers crossed the narrow catwalk one careful step at a time.
tighten that clamp.
Crews tightened the temporary cables and secured every connection.
Cable tension is optimal here.
Before cable work began, the catwalk had to pass inspection. The temporary catwalk finally connected both towers across the void.
Tension check on line 3.
Now the bridge was ready for main cable spinning.
Engage the main winch slowly. All right, engage the pulling wheel slowly now.
The first steel wire strands were pulled across the span. A spinning wheel carried wire back and forth above the catwalk.
Roger, Traveler is slowing down, approaching the marker. Secure the anchor plate now.
Strand by strand, the main cable slowly took shape.
Uniform before we proceed.
Workers inspected spacing before the bundle could be compacted. Hydraulic equipment compressed the wires into a stronger cable. Cable bands were installed to prepare for the hangars.
Lower the line. Hold it there, watch the...
The first vertical hanger cables were positioned below the main cable. Hanger cables began to define the future load path. Engineers checked spacing, tension, and alignment before lifting steel.
Tension set on line 3. Copy that, moving to position 2.
The cable system was ready to receive the truss girder.
Hold it right there, ease it down slowly.
On the ground, steel truss sections were assembled for lifting. Heavy transporters moved the segments toward the lifting zone.
Apply tension to the forward slings.
Slings, shackles, and winches were checked before the first hoist.
All right, winch, bring her down 5 meters. Watch the alignment on bay 4. Copy that, moving slow. Wind is pushing hard.
The first truss segment hung above the canyon under cable control.
Bring it left, slowly. Lowering now, hold the tension on that line.
Workers guided the steel into position using tag lines.
Guide it left, just a little more.
Okay, hold it there.
Bolts locked the first segment beneath the hanger cables.
Sequence on the far side.
More truss segments approached the growing suspended structure.
Steady. Ease left, just a fraction. Aligning now.
Hold it steady, minus 10 millimeters on the east side. All right, taking tension now.
Alignment had to be measured in centimeters, not meters. The truss line extended outward, but the span remained incomplete. Another heavy segment rose from the canyon side lifting zone.
We're getting rotation on the south end.
Tag lines controlled rotation against wind over the canyon. Hanger connections transferred cable force into the steel truss. Workers bolted diagonal members high above the valley floor.
Moving to the next bolt.
The unfinished truss reached farther toward the center gap.
Hold the tension steady, slow the winch now. We need alignment on the south side. Copy that, adjusting tag lines, ready for final placement.
Every connection plate became part of the bridge's skeleton.
Send it.
Inside the truss, crews tightened high-strength bolts by hand.
Is the alignment correct now? Yes, it's with...
Engineers checked the joint geometry before moving forward. Final steel connection work secured the growing girder line. Survey teams verified that the truss stayed on its designed path. Hanger-to-truss connections were inspected under real construction load. A long steel section was now locked in place. But at midspan, one final gap still remained open.
Alignment confirmed. Ready for the next lift.
All right, bring her down slow. Hold the tension on the east cables.
The closure segment arrived above the deepest part of the canyon. Workers guided the final piece into a narrow steel gaps.
Check the pins on your end.
Hold it right there. Looks good. All right, dropping the pins in now.
Temporary pins held the closure segment before permanent bolting. Permanent bolts finally connected the two sides of the truss.
Alignment confirmed. Proceeding.
Engineers inspected the closed joint before deck work could begin. Deck panels were lowered onto the connected steel truss.
Watch the clearance on the right. Slow, slow, and stop.
Crews aligned each panel before locking it into place.
Hold it steady.
Bolting and welding turned separate panels into one deck system. The deck surface expanded across the suspended span.
Coming down now. Looks good. Set it, set it.
Edge barriers and safety systems were installed along the deck. Waterproofing prepared the surface for its final wearing layer.
I'm running the squeegee over it now.
Paving equipment completed the bridge deck under construction control.
Hold the line steady.
Sensors were installed to monitor the bridge's structural behavior.
Stable now. Go ahead and torque the bolts.
Engineers checked cables, hangers, and connections before load testing.
Looks good. Proceed with tightening sequence.
Under the deck, crews inspected joints hidden from normal view. Survey teams measured deck alignment across the full span.
Reading stabilization.
Confirmed. Reading accepted. Team B, confirm readings on Sector 4. Over.
Final safety systems were checked before heavy test vehicles arrived. Monitoring teams prepared to read the bridge under load.
Shows slight anomalies on speed. The cable tension is
All right, team, confirm positions.
Load testing began with heavy trucks positioned on the closed deck.
Reading stable on my end.
Convoy leader, report speed.
The test convoy moved slowly onto the suspension span. Static load positions helped engineers measure the bridge response.
Show consistent strain levels. Wind advisory remains in effect. Reading stabilizing at 0.05.
Sensors recorded deflection, vibration, and structural behavior.
Sensors active.
The dynamic load test pushed the structure through controlled movement.
structure holding steady.
Cables and hangers carried the test load through the system.
Acknowledged. Readings confirm minor wind resonance. Structural integrity nominal.
Below the deck, inspectors checked the truss while trucks remained above.
Copy that. Moving to 8.
Look at the
Engineers reviewed the data before approving the final stage. The load test ended with the bridge still stable and controlled.
Acknowledged. Proceed with securing the site.
After years of construction, the span finally crossed the canyon. Vehicles could now pass where the valley once divided the route. Cables, hangers, towers, and truss now work as one system. The bridge does not erase the canyon, it conquers the crossing. This is how engineers built across one of China's deepest mountain gaps.